Welcome back to another exam walkthrough. We're going to be going through A-level physics, paper 3. This is going to be from AQA Engineering Physics, June 24. Question number 1. So it says a heavy turntable is mounted on a fixed base. The turntable can rotate freely on a low friction bearing. Figure 1 shows a propeller unit fixed to the center of the turntable. The propeller unit consists of a motor-driven propeller and a battery. The propeller and the turntable have a common axis of rotation. Now we're going to get to the main part of this question, which you have to focus on. So it says at first the turntable and the propeller are at rest. That would mean that the sum of the angular momentum initially is equals to 0. And then it says the propeller motor is switched on and the propeller quickly reaches a high final angular speed. The propeller rotates clockwise when viewed from above, so it's going to rotate in this direction. Compare with reference to angular momentum the motions of the turntable and the propeller. Alright, so the sum of the initial angular momentum is 0, and we can also say that the sum of the final angular momentum must also be equal to 0. So the sum of the final angular momentum right now is going to be the angular momentum of the propeller. I'm going to take clockwise direction as positive. Now to remove this, to cancel it out so that it becomes 0, the turntable must move in the anti-clockwise direction. So I'm going to write minus L angular momentum and T turntable. Now I want us to focus on the angular momentum of the propeller and the turntable. The angular momentum of the propeller must be equal in magnitude to the angular momentum of the turntable, but they both must be in opposite directions. And the reason for that is that when you add them up, they're going to have to give you 0. So they're going to have to be the same thing, and the signs have to be different, so they must be in opposite directions. Alright, so that's all for the first part. Now I have to explain you one more thing. Let's talk about the angular momentum of propeller. That's going to be the moment of inertia of the propeller times the angular velocity of the propeller. And let's talk about then the angular momentum of the turntable. That's going to be the moment of inertia of turntable times the angular velocity of the turntable. So let's talk about the moment of inertia first. Now, the moment of inertia depends on the mass distribution and the distance from the axis of rotation. A greater mass of the turntable is located further from the axis of rotation than the propeller. And we know that the moment of inertia is equal to the sum of m times r square for every tiny mass. Okay, where r is going to be the distance from the axis of rotation for every tiny mass, and m is going to be the mass of every tiny mass, and then when you multiply m and then r square for every tiny mass and you sum them up, that's going to give you the moment of inertia. Now if a greater number of tiny masses, or a greater number of your mass, a greater proportion of it is located further from the axis of rotation, then what's going to happen is that your moment of inertia will become bigger because it's dependent on that r square, right? So when that r becomes bigger and bigger, so a greater number of masses are further away, the moment of inertia is more. And because of that, we can say that the turntable will have more moment of inertia than the propeller, because you can see that there isn't a lot of mass that's located further from the axis of rotation for the propeller. So the moment of inertia of the turntable is greater than the moment of inertia of the propeller. I hope that's clear. I've repeated my points a few times as well. Now, this is going to be greater, this is going to be less, and this is constant. Because of this, what we can say is that the angular velocity of the turntable is going to be less and propeller is going to be more. Okay? Like what you're going to write down is that the sum of the initial angular momentum is equal to the sum of the final angular momentum. You can also write that the net external torque is equal to 0. That's up to you. And the second point you're going to write is that the initial angular momentum is equal to 0. So the final must also be the same. And because of this, the angular momentum of the turntable will be equal in magnitude to the angular momentum of the propeller, but opposite in direction, so it's going to be anti-clockwise. And then finally, you're going to talk about the moment of inertia. So moment of inertia of the turntable is greater than the moment of inertia of the propeller. So the angular velocity of the turntable will be less than the angular velocity of the propeller. So these 4 points are going to be the best thing that you can write to get the 3 marks. All right. And now I'm going to show you the mark scheme and examiner report. And then we're going to end the video there.